Alright, so remember how yesterday when we did the log facts we talked about some shortcuts that we could do? There are special rules for logs that we can use so that we don't have to actually really do any work, okay? So if we have a base and the exponent is a log and the two bases are the same here, our answer is just going to be that exponent. Okay? So if you ever get a problem and we have a base raised to a log with the same base, it all ends up canceling each other out and our answer is just the x, what we are taking the log of. We will do an example with numbers in a second. Okay? And then remember yesterday how if we had a problem that was like log base 6 of 6 squared, the answer was just 2. So when we have log base b of a b, our answer is just the exponent right there.
Wait, so
okay. Or if we are ever taking the log of any base of 1, it was always what? 0. Okay, that's the big one that we looked at yesterday. Okay, just a reminder, remember our same rule as when we have exponents, b and y, so your base and your answer must always be positive, and our base can also not equal 1. Okay, so that was rules that we talked about in 8A, so it's just a reminder there. Okay, so let's look at an example. Okay, example 1. So this is the first rule. I have 6 to the log of 6 of 25.
27.
Oh my gosh, 27, thank you. So 6 to the log base 6 of 27, that 6 and log base 6 cancel each other out, so my answer is just 27. Okay, this is kind of an easy rule to remember because we don't see it that often. How often have you guys so far seen log in an exponent? All the time? Okay, we don't see that often, so if you ever see that, your answer is just the number that we're taking the log of. Okay, so what about number 2? I have log base 3 of 3. So what's my answer going to be? 5. That log base 3 and the 3 cancel out, so our answer is just 5. Okay, what about number 3? It is 2, because if I have just log, that actually has a base of what? 10, and it's being, the base of that exponent is also 10, so they cancel each other out, so my answer is 2.
But isn't it log 2?
If it just says log, the base is 10, remember? This is the same as 10 to the log base 10 of 2, and that's this rule. Okay, what about log base 6 of 36? How can I rewrite 36? 6 squared. So this is log base 6 of 6 squared. So my answer is 2.
Oh yeah, I thought it said log 2. I thought it said log 2.
Okay, so what about number 5? This is the same as log base 5. 25 is, or 125 is 5 to the third, and we have to multiply it by that x, right?
Yeah.
So that log base 5 and the 5 right here cancel each other out. So what's my answer? 3x. I keep the entire exponent. And then log base 4 of 1 is always going to give me a 0, which we learned yesterday. So as a reminder, if there is no base shown, we assume it's a base 10, and that was called the common log. Okay, so let's do examples 6 and 7. Look at number 6.
Wait, are you going to explain the stuff at the top?
This is just saying that if I have log base y of x, and my log is log base 10 of y, that's the same as 10 to the x of y, right? It's just rewriting it, explaining that if I have log of y, we can rewrite it as log base 10, and then when you go up and around. Make sense? Okay. So, log of 10. Let's first rewrite this. That would be log base 10 of 10, and what's the exponent there?
1.
It's just a 1, right? So what would my answer be? 1. If it has no exponent, the exponent is 1. So what about this one? This would be log base 10 of 10 to the 1,000 is 10 to the third, but we need to bring it up, so it would be 10 to the negative 3. So what's my answer? Negative 3. Good. All right, so in math today we are going to talk about a new number. The number is called E. Okay, thank you. It's an irrational number, very similar to pi. Okay, so pi is a special number that always means 3.14. E is a special number that is always about equal to 2.718. It's called E, named after a mathematician named Euler, but he spelled his name E-U-L-E-R. Okay, it's not Euler, it's Euler.
It goes 1, 2, E3.
Okay. Now E is a number that we use a lot in calculus, trigonometry, and so we are starting to work with it in Algebra 2. When we take a log with a base E, it's a special kind of log called a natural log, and what I would like you to do is just put a big box around it. Okay, it's a special log called a natural log, and instead of writing it as log base E, we use the notation ln, okay, and that stands for natural log. We use natural log a lot in calculus and pre-calculus, so if any of you are taking advanced math next year, going into calculus at some point, you will be using natural log a lot. Okay? Alright, so if you ever see ln of x or of y equals x, that's the same as writing log base E of y equals x. So natural log is the same as saying log base E, and when we go up and around, that would be base E to the x equals y. So we still follow the exact same rules, it's just a different notation when we have a base of E.
Is that the same thing for pi also?
Pi does not have a special type of log, but we still do everything exactly the same. Okay, so for our example 8, when we want to write it in exponential form, we start at pi, so our base is pi to the exponent 3, and that's going to equal 31.01. So we still do everything exactly the same, we're just using pi as our base this time. Okay. So for number 9, I have a natural log of 20.01 equals 3. So what's my base going to be? E. So that's going to be E to the third equals 20.01, and that's your answer. So anytime you see natural log, it's just like when we see log with no base, always has base 10. Natural log always has base E. Just something we have to know. So that's natural log and all that good stuff. Let's actually graph. Okay, so graphing a log equation is actually almost exactly the same as graphing exponential functions like we did in 8A. The first, we just have an extra step we have to take. We're going to rewrite in exponential form, and then we're going to make a table of values. And here's something that differs from our exponential form. We need to look at the equation and see which letter, x or y, is going to be the exponent. So now we might sometimes have y in the exponent instead of x, which is a little bit different. And it's going to make our graph look different also. Okay, so whatever the exponent is, we're going to plug in the numbers 2, 1, 0, -1, and -2 into that column. So we're going to make a table or a chart just like we did in the last unit. But if our exponent is y, we plug in these numbers for y. If our exponent is x, we plug in these numbers for x. Okay? So whatever your exponent is, that's where you plug in the numbers. Okay? And then we're going to plot those points and graph them. So, looking at example or number 10, we first have, we want to graph y equals log base 3 of x. So let's first rewrite that in exponential form. Y is on the other side, so we're going to have to go around backwards than what we're used to, but it's still going to be base 3 of, or to the, sorry, 3 to the y equals x, right?
So you go backwards.
Yeah, because y is on the other side. You can rewrite it so that y is on the right if you want, but you can do it backwards. Okay, so 3 to the y equals x. So what's my exponent here, y or x? My exponent is y, so I plug in 2, 1, 0, negative 1, negative 2 into y. So we're plugging the numbers in for the exponent. Okay, so I have a feeling this is going to make my graph look a little bit different than what we're used to, but let's see what happens. If I plug in 2 for y, x equals what? 9. 1, 3, 0, 1, negative 1, 1/3, and negative 2, 1, 9. Okay. Now all we want to do is plot these points. Now remember, even though we plugged in our numbers for y, we still plot exactly the same, x comma y. So my first point is going to be at 9, 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then up 2. So my first point is right here. My second point is at 3, 1. 1, 2, 3, up 1. Next point is 1, 0. So 1, and I stay on that x-axis. Next point is 1/3, negative 1. So 1/3 is somewhere about here in between 0 and 1. And my y is negative 1. So it's going to be right here. And then my last point is 1/9, so that's even closer, at negative 2. So somewhere right here. So let's draw a curve through these. What is it going to look like? These do cross the x-axis, but look at it. Do you think it's ever going to cross the y?
No.
Nope. So it's exactly what we've been doing, it's just turned on its side now. Why do you think that is? What changed from this graph than what we graphed in the previous unit?
Why is it so?
The exponent is y this time, and all the times before the exponent was x. So if our exponent is y, we will cross the x-axis, but we will never cross the y. If our exponent is x, we cross the y-axis, but we never cross the x. Does that make sense? Okay? You guys good so far? It's the same thing that we did last unit. The graph just looks a little bit different turned on its side. Okay, so let's look at number 11, last one. Okay. Okay, so we want to graph both of these on the same grid. So the first one is given to us in exponential form, y equals 2 to the x. What's my exponent there? X. So I should have, this is a typo, I should have plugged all the numbers in to x. What I did was I copied and pasted and then forgot to change it. So my x's should be filled in, not my y. So it should be 2, 1, 0, negative 1, negative 2. Okay. Yeah, because the exponent is x, and so we were supposed to plug him in. Oh. Yes. Yeah. I understand what you're saying. Okay, now this one, the first thing we want to do is rewrite this in exponential form. So this is going to be 2 to the y equals x. So I plug in these numbers for y because y is the exponent. And then let's plug everything in. So if x on this one, the pink one, if x is 2, y is 4. 1, 2, 0, always 1, negative 1, 1/2, and negative 2, 1/4. Let's graph that one first. So that's going to be 2, 4, 2, 1, 2, 3, 4, 1, 2, so 1, 1, 2, 0, 1, negative 1, 1/2, and negative 2, 1/4. So somewhere right here. So this graph looks like what we're used to, right? Review question. Is this one increasing or decreasing?
Increasing.
Increasing. Good job. Okay. Now let's look at the blue one. So I plugged in numbers for y. So if y is 2 x's, 4, 1, 2, 0, 1, negative 1, 1 half, and negative 2, 1 fourth. Okay, let's graph that one. This one is going to look a little bit different. First point is 4, 2. So 1, 2, 3, 4, up 2. 2, 1 is the next point. 1, 0. 1 half, negative 1, so somewhere right there. And 1 fourth, which is even closer to the y-axis, and negative 2. So let's graph that one. So we will always get really, really close to the y-axis on this one, but we'll never actually cross it. And those are our two graphs. So these are exactly the same except for the one change where x and y are switched. What is it called? What happens when x and y are switched? Do you guys remember? When you switch x and y, you're finding the inverse. Good job. Okay.